All right, so we're looking at the inverse relation. We know this is a relation, not a function, because it's the equation of a circle. So we're looking at the equation x minus h all squared plus y minus k all squared equals 1. Hk is the centre. So you can see here that 3, 0 is the centre of this circle. So let's pretend this is 3, 0 right here. So we're saying this is the centre of the circle. What's the radius? The radius is 1. So we'll go here, 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 and here. So good luck drawing a circle there. So we've got 4, 2 down here. We've got 3 minus 1, and up here we've got 3 plus 1. All right, so that's our function. Now, if we want the inverse, our relation, if we want the inverse of that, we just sub x in for y. So we're swapping all x's and y's. So it now becomes y minus 3 all squared plus x squared equals 1. All right, so that's our inverse of the relation. Now, we know the original is a relation, and also we can do a vertical line test. So, so it's a vertical line test to test if it's a function. If the relation, or the function, the original one, if we're looking to see if it has an inverse function, we can do a horizontal line test. So we've inversed the vertical line to a horizontal line. So you can see, if I do, I think you can see the ruler on top, you can see that any horizontal line here is going to pass through more than once, or at least there's one point, at least, in this case many, that it passes through twice. More than once. So we know that the inverse will be a relation, not a function. All right, so if I'm graphing this new one, let's do it in green for the inverse. You can see now the center is x equals 0 and y equals 3. So 0, 3, let's put it, say, here on my y-axis. Again, the radius is 1, so we're going to go 1, 1, 1, like that, where that's 3, so that'll be 2. All right, so we're going across to 1, 3 here. This will be 4. This will be across at negative 1, 3. All right, so you can pick points as well and reverse them because our x's become y's. So for example, this point here on the curve is 2, 0. And if I swap them, I get 0, 2, which becomes this point here. So this point here becomes this point. Why is that so? Because remember, an inverse function, inverse relation or function, we graph, we're just graphing the around the line y equals x. We're moving everything that was x to y and everything that was y to x. So this line, you can see that, that point will become that point over there. Same with, for example, let's take this point. So 3, 1 becomes 1, 3, which is that point, you can see. So these lines, of course, will be perpendicular to that y equals x. So that's how we find the inverse graphically, and this is how we find the inverse, this is how we find it geometrically, this is how we find it algebraically. All right, so what's the domain and range of both? So the original, the one we started with, the domain, you can see it goes from 2, and it includes 2, all the way to 4, and it includes 4, and the range goes from down here, so at negative 1, including negative 1, up to 1. Now you can see when I go to our inverse, up here, the domain now goes from negative 1 to 1, which you can see is exactly what our range was. And our range goes from here, from 2 up to 4, which was exactly what our domain was. So they also swap, just like our x, all our x's, and swap with our y's. Our domain and our range will also swap. And of course, yes, this is a relation here.